Now, lately we've also been talking about the greatest common divisor, and now we're talking about the LCM, and I think students will often get these confused when they're first starting off. So I think I want to pause here and say a couple of things about them so that you don't confuse them, to help you unconfuse them. So here we go. Whenever you think about greatest common divisor, if you think about GCD, you should think reduced fractions. That's what you should think. I'm going to give you an example. Suppose you think you want GCD of 8 and 12. Think reduced fractions. So just pretend it was a fraction, just so you can wrap your head around the greatest common divisor. Just pretend for a second it was a fraction. It's not, but pretend it is. And so then you would think, oh, this is 2 times 2 times 2, this is 2 times 2 times 3, and this is what's common. There's a 2 that's common, there's a 2 that's common, and there's nothing else that's common. So the GCD is 2 times 2. That's what's common. So whenever you think about greatest common divisor, think reducing fractions. This is the GCD, 2 square, okay? Or 2 times 2, whatever you like. Again, GCD, think fractions. So all these things, they're separated by comma. Put one of them on the top, and it helps if you're a beginner. You might want to put one on top and use the natural exponents. This is x, 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 5 of them. Put the other one on the bottom. This is 2, 2, 2, 2, 4 of them. This is 3x's, and this is 6y's. Greatest common divisor, think fraction and think what's common. Okay, I got 3 of these common. I got 3 of these common, and I don't see anything else that's common. So the GCD is 3 of these and 3 of these. Boom. GCD, think fractions. It's not really a fraction. Use this so you can understand and help you remember how to compute the greatest common divisor. On the other hand, when you're thinking about the LCM, think add fractions. This is a totally different idea. For example, to find the LCM for between 8 and 12, think this is something over 8 plus something over 12. It's not, but if you think about it, it'll help you remember what the LCM means. LCM, you should think add fractions, and so you think this is 2, 2, 2, and this is 2, 2, 3, and you think what would they both need so that they have the common denominator? They both need 3 2's, because this one 2 and this one 3. They both need 3, and they both need a 3. That's your LCM right there. So the LCM is 2 to the third times 3. Okay, all this is just so if you have trouble remembering what they are, this will help you remember. Prime factorize and pretend that you were adding the fractions. Okay. Again, LCM, think add fractions. So here I have 2, 2, 2, x, 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 x. And once you get good at it, you don't have to write this stuff. You can imagine it. 2, 2, 2, 2, x, 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 y, 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 y. So to get a common denominator, you would need the same number of 2's. This one has 3, this one has 4. I need at least 4. To get the same denominator, I would need the same number of x's. This one's got 5, this one's got 3. I would need both of them to have 5. So I could supply 2 of them here using jot. I would need both of them to have the same number of y's. This one's got 6 y's and this one has no y's. So I need both of them to have 6. So the LCM would be 2 to the 4th, x to the 5, y to the 6th. Okay? So whenever you think LCM, think adding fractions. Hopefully that helps you keep the distinction clear and helps you remember how to compute each of them. Alright, so we added fractions several different ways today. With the same denominator, we discovered the ATT theorem. We proved it. With different denominators, we discovered that we can unsimplify these either by doing the raw, where you just take each of the denominators, or doing the professional way where you prime factorize and look for the LCM. And now I think we should take a moment just to, I know a lot of you guys love shortcuts, and if you wanted to see the shortcut on how to do this, that's what we should do now. I wanted to show you the shortcut. The shortcut is that you go to this website and you type things in here, like for example, suppose I wanted to do 1 over 8 plus 5 over 12. 5 over 12. Then you just hit enter, and boom, there it is. That's the shortcut. Haha. 13 over 24. If you want shortcuts, this is a shortcut. If you want to understand it, if you understand what you're doing, do the prime factorization, do the LCM, do these things. It's beautiful. Alright? Alright, we'll see you guys next time. Peace. Cut.